right now, I have to review it. I really should have looked at this beforehand as well. We'll get through it. We'll put this under the heading of function. There is a good chance that I will get about 10 sentences in this and say, let's quit because I don't remember this. But there's a good chance I won't. Okay. The best way to talk about this is this. Okay. If you went back to our little, let's say we have a linear equation. Remember linear equations? You probably don't. That was where y equals like 3x plus 1. You remember that? Somebody?
Yes.
Remember doing the little tables with those?
Yes.
Where you got to pick the x values and you came up with some y values. Let's just do easy ones because I know you're not much into thinking today. 0, 1, 2, 3. If I put 0 in for x, I'm going to get what for y? Anybody? Shout out the answer. Good shout. 3 times 0 is 0 plus 1 is 1. Oh wait, I heard a 4. Thank you. 3 times 1 plus 1 is 4. Anybody on the 2? Anybody for 2? Somebody for 2. 3 times 2 plus 1. I could go get some second graders if this is too hard for you. 7. 3 times, look at how quickly that is there. Okay, when we talk about, this by the way, this is what we call a function. Okay, a function is when you put a number in, comma, you get, all right, here's the key that you have to write down. When you put a number in, you get 1, and only 1 number out. I am going to let you, actually, let's all say that together. Put a number in, you get 1, and stress only 1 number out. I should just stop right there because apparently you understand that. Okay, so here is the deal with that. The number we put in, I'm going to do this. The book shows it like this. They show it as what they call a mapping. This is really a mapping. I put in 0, 1, 2, and 3, and I got out 1, I got out a 4, I got out a 7, and I got out a 10. You remember when you started yelling out all those answers and I had to calm you down because you got so excited about that?
Yes.
This is what you got out. Now notice this is a function because I put 1 number in and got only 1 number out. Only 1 number out. Before we go any farther than that, we have some definitions. The number we put in, okay, our input number is what the people in the math world, and notice I didn't say I myself because I'm not sure why they talk about this. This is called the domain number. I have to change colors because that's not, if you're lucky, this may take us all the whole time today. The domain number. The output number is anybody? Home on the, thank you, range. The output number is the range number. Pause for dramatic reflection. Okay? Which means I could change and put these words into my little things. If you put a domain number in, you get 1 and only 1 range number out. To which you're going to say, well.
Well.
All right, let's think about this for just a moment, though. Alright, let's say I have a different mapping of numbers. Here is my domain, and I have a range, and I have, let's just say I have 1, 2, and 4. And over here I have 5 and 3. And I asked you, is this a function? Exclamatory mark there, question mark. Who, based on the definition of what we just gave, that every domain number has just one range number to it, who says, yes, this is a function? Great. So far, I am a failure at teaching this. So you're telling me that 0 has more than one answer. What answer goes with 0? 5. 2 has more than one answer?
Yeah.
Okay, what 2 numbers does 2 go to?
Just 3, and only 3.
4, what 2 numbers does 4 go to?
3.
Only one number.
So
So, and that, ladies and gentlemen, is where people get mixed up here. If you follow the exact definition there, every number of the domain goes to only one number of the range. It can be the same number. I could just have a 3 there and have all of them go to 3. This is, yes, this is a function. Exclamation point. If you think of the whole spiel there, 1 and only 1 is where it goes. Now, let me change it up a little bit here. For those of you that said no. Here is 0 and 1, and here I have 3, 4, and 5. Is this a function? Here's my domain, and here is my range. Here, this is my function there. Is this a function, yes or no?
No.
No. Why? Because there is this domain number that has 2 different answers to it. So this is a big fat no. Now, lest you thought you were confused so far, let me confuse you just slightly more. You can write domain and range numbers going back to this. Where'd it go? You can go back to this and not write it in table form, actually write it in point form, ordered pair form. Here are all my points. Is this a function, yes or no? Let me give you a clue. It's the same as this. These are the same thing. Is this a function? Was this a function? Yes. How would you know if ordered pairs were not a function? What would have to happen? Going back to the definition that says every domain number can only have one range number, what would make an ordered pair, a group of ordered pair numbers not? Anybody working with me here? Yes, Mom and Dad. I spent the whole time talking domain and range and nobody asked me a question. Let me give you some for examples here. What if I have this? 7, 7, 2, 8, 3, 5, 2, and 3, 6. Function or not? Oh wait, let me throw another one in there. 8. No, let's not do that. Let's do, oh no. Don't worry, I can go back. Wait, where'd it go? Sorry. I'm gonna do, let's get rid of that. What if I did 3, no, yeah, let's do 3, 3. Sure, why not? Function or not?
No.
Who says yes? 1, Somebody please be bold. Remember the last time when everybody was wrong?
I'll be
I
bold.
sense it happening. Now, who says no? Who can justify? Why no, Aaron?
Because 3 has 2.
Exactly. This is not a function because, see, here, let me do this. All the domain numbers are in red. All of the range numbers are in a shade of green and blue. If I were making a mapping sort of thing out of this, doing the little arrow thing, let's do that just for fun because I can tell you are mesmerized by this whole thing. If I were doing that whole thing, what are my numbers on the left? It looks like I have 3, 5, 7, and 8. Well, 3 is the same as a 3, so. And 3 goes to 6, and 3 also goes to a 3. 7 goes to a 2. 5 goes to a what? 2. And 8 goes to a 3. Which one can't you have? You can't have this because you have the same domain number going to 2 different ranges. This is not a function. I can have 2 different domains going to the same range, but it can't work the other way around. How many of you feel very excited about that? Now, let's throw this at you here. Can I go back to that original screen?
Yes.
Mostly I can. Why can't I?
Because you have the button.
Because I am.
You're Mr. Teacher. You are an amazing teacher.
No, stop. Stop it now. That does not make me feel good. Okay, here we go. I've got this. If I were graphing this little thing, we can graph this, right? Because we have graphed stuff like this before. If I'm graphing this, I get 0, 1, correct? I get 1, 4. I get 2, 7. I get 3, 10. It was a linear equation because it's a linear function, okay? And that's what you get. We have such a thing in mathematics. In order to figure out if something is a function, we have what's called the vertical line test. And you want to know, this will come up a lot, so make sure you know this. Vertical line test, which says this: for something, when you graph something, for it to be a function, comma, you cannot draw a vertical, it's called the vertical line test for a reason. You cannot draw a vertical line that will be intersected by a graphed line. Remember when I said I wanted to quit this whole lesson? That's where I'm at right now. In more than one way. That's a big exclamation point there. Oh, what time is lunch?
In 10 minutes.
If anybody can guess what I am having for lunch today,
Okay.
I will stop right here.
Let me think.
I will give you 30 seconds to say out loud what you think, and if I hear it, we'll stop. Nothing.
Name something.
I will tell you if somebody actually says it, but nobody said it.
Soup, oatmeal, cereal, hot dog, chili, hamburger, salad,
Nothing.
anything that's on your mind. Fries,
Meatloaf, chicken,
pork, steak,
nuggets.
Stop. You did get it. Alright, I'll tell you later. This means this. If you graph one of these relations or these ordered pairs or whatever. The vertical line test says this, and this is really have to think about it. These words are just a bunch of gobbledygook. You sit here and you take, vertical by the way means up and down, you sit and go like this through your entire graph. And if you can draw a vertical line where my blue line of graph would cross it in more than one place, it would not be a function. Would not be a function. But this doesn't, so it is a function. Now, it helps if you do a couple examples where it actually happens. Here, so if my graph of a line was like this, which does happen, this is not a function because I can just do that. There's my vertical line. It crosses it actually in 3 places. Okay? The vertical line crosses it. And if you think about it, it makes sense, Andrew. Because remember when we went back to the ordered pairs and we said the same x value cannot have more than one y value? Well, here is, if this x value is 1, and I was doing an ordered pair, this would be 1, 0, but this would be 1, like 4. And this would be 1, like negative 4. So in essence, I have one domain thing having 3 different range things, and that can't happen. Now, don't get that mixed up with this, because people sometimes do this. Is this the graph of this line? Is that a function? Oh boy.
Yes. Yes. Yes.
Yes, because you would tell me to say vertical line test. I can draw all the vertical lines I want, and nowhere will I get this red line to cross one vertical line in more than one place. Here. So, if I had a circle, is a circle a function? No. No. Why?
Vertical line.
Thank you, whoever said vertical line test. Don't give me the bullets because it crosses a vertical line. It crosses in 2 places there. Can't happen. Now, there is no such thing as a horizontal line test. Okay, I mean, it's always vertical. How much have you? No, still nobody guessed.
Pizza.
Somebody already said pizza.
Chicken nuggets.
Take a look at page 149. We will finish. We will wrap up with this. See if you can make heads or tails of this. Let's just look at the practice problems. 5 minutes will go by quickly, then you'll be out of here. Look at page 149, letter A. It says to give the domain and the relation. Domain and range of the relation. What would you do for letter A? Simply this. You would say the domain equals, and since you're going with a set of numbers, what would my domain be for those set of numbers? The domain would be all of the x numbers, which are what? What are the x numbers? 1, 2,
4, 8, 7, 3.
I would probably put them in order if I were doing this. And the range would be all the y numbers, which are the
2, 1, 6, 5, 7, 10.
look at Grace.
Go Grace.
Nice. Pretty simple answer there. By the way, no, we don't answer that. Letter B. Use a diagram to determine whether the ordered pair represents a function. Well, that would be that whole mapping thing where you draw the little circles, in which you would do this. The first one is what? 11 goes to 12. So you do an 11, draw an arrow, it goes to 12. You have a 12, it goes to 1. You have a 5, it goes to 5. Who to what? 14 to 10. And a 13 to 7. Is that all it is?
Yes.
So that, wait, we missed something. No, that's right, that's fine. So those. Oh, does it represent a function then? Yes or not?
Yeah.
Yes.
Yes. What about letter C? Determine whether y equals 3x minus 1 represents a function? Yes or no? Anybody know why that would? Y equals 3x minus 1? You know, you could make a table and just do a few things and see what happens. You know, did I do this one right? Was that the one?
It
I
was
did?
+1.
0, 1, 2, and 3. 0 gives you negative 1, 2, what? No. 0 gives you negative 1. 1 gives you 2 gives you 5, 3 gives you, are you ever going to get the same number to give you 2 different answers? When would you have the same number to give you 2 different answers?
What?
Does anybody know? How about this? Here's where it would be. Where you get y would equal the square root of x. Why would that? Let's stop on this because this is a fun thing. If I made a table of this, children, remember you get to pick any x numbers you want, so pick smartly.
7.
No.
Chase. Come on, Chase.
What would you put in for x that you could actually find the answer?
2, 4.
No. You can't find the square root of 2. It's an irrational
9.
number.
I'm sorry.
9, 16, 49.
Here's the deal with 9. What is the square root of 9?
3.
It's not only 3, because 3 times 3 is 9, but it is also negative 3, because a negative 3 times a negative 3 is 9. And what else could we do? We could do 1. Square root of 1 is both negative 1 and positive 1. The square root of 4, what times we use it for, is 2 and negative 2. The square root of 0 is 0. And I know you're going to say, wow, what would the graph of that look like?
Wow.
The graph of that would look like this. What color shall we use? 0 is 0, is it not? 9 is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, and negative 3. 1 is positive 1 and negative 1. 0 is 0, 4 is 2, negative 2. 4 is 1, 2, and negative 2. Here's the graph of the square root.
That's the ugliest shape I've ever seen.
So that would be a no for the function.
That would be a very, very hard fast. Technically, we have to overrule some things. Anyways, who's praying? Let's go.